Let's explore high availability and failover design. We're going to start off by focusing on high availability, and let's define what high availability means. High availability essentially means a system is available most of the time. And generally speaking, in order for systems to be available most of the time, we usually design those systems to avoid single points of failure. In other words, to build in redundancy into the design. And redundancy in the cloud is mostly achieved by deploying resources across multiple failure domains. Usually with a high availability design, we make use of load balancers. Load balancers typically work alongside health checks that monitor the health of backend systems. And the load balancer uses that information to distribute load to systems that are available and that have the capacity to serve the additional request. It is also important to note that it's not possible to achieve 100% availability, and also achieving a very, very high level of availability, for example, 5 nines, it may be very expensive to implement. Let's move on and have a look at failover design. Failover design refers to the ability to survive a hardware failure. And in the cloud, this is typically achieved in partnership with the cloud provider. And most failure designs require a backup process or a backup solution. Let's move on and explore disaster recovery. We're going to start off with an overview of disaster recovery. Disaster recovery is the design or mechanisms that are implemented to enable recovery during the failure of an entire region. A failure of an entire cloud region is typically caused by human error, that is configuration error, and occasionally it may also be caused by man-made or natural disasters. There are two common ways of configuring disaster recovery, that is a hot standby or a cold standby. Let's start off by exploring the hot standby option. The hot standby option is a design configuration where resources are duplicated across at least two regions. A load balancer is then used in order to route traffic across those regions. There are certain services in the cloud, for example, cloud storage buckets, that offer multi-regional configuration where data is duplicated across multiple regions, and this provides built-in support for disaster recovery. Generally speaking, in a hot standby configuration, resources are readily available across all of the regions or can be made available in minutes. Let's move on and explore the cold standby option. With the cold standby option, data is synchronized across two regions. However, one of the regions is the primary region used for delivering services, and the other region is a backup or standby region. The backup or standby region is only used in the event of a disaster. In the event of a disaster, the DNS and load balancer are reconfigured in order to route requests to the backup region. Given the need to reroute requests to the backup region, this type of design is only suitable for applications that can sustain a period of downtime. In this section, we've explored a number of high availability and failover design options and principles. In subsequent sections, not only are we going to go deeper into the subject, we're also going to have an opportunity to explore the implementation of these design concepts and principles in services available on the cloud.